All right, so we're in section 13.2 where we get to define general angles and also use radian measurements. First thing I want to discuss is about being able to figure out how to create an angle on a quadrant plane. This arrow here to the right is considered the initial side, so that's where you would start your angle. You always would start it, like say, on the positive portion of the x-axis. So, and then the terminal side is whatever side that angle happens to be, and then whatever that arrow is is going to be theta. So if I end up going counterclockwise, theta, whatever that may be, is going to be a positive number. If I go clockwise, it's going to be a negative number. So that being said, I want us to be able to draw angles in their standard positions. So we have 135 degrees. Now, what I do know is this, is that each quadrant represents 90 degrees. So here is, this makes it 90, this makes it 180, this makes it 270, and then this brings it back to 360. So knowing that, I can then implement and figure out roughly where my angle for 135 is going to be located. So I know that it's going to be in this second quadrant here, somewhere around here. And I know that if I take 135 and minus by 90, I get 45. So it looks something kind of like this. So the angle's somewhere right around here. And then they just kind of draw something like this, and I put 135. All right. If I'm dealing with 455 degrees, I notice that that is larger than 360. So all you have to do is to figure out roughly where it's going to be located is take 455 and subtract that by 360, and we get a value of 95. So since we know that it's in the realm of 95, I know for a fact that it's going to go around this one time. So that's where it's 360, and then they want us to go another 95 degrees, which would say it would be something right around here, and then I would finish it off looking like this, and then put it as 455 degrees. The last one I have is negative 100 degrees. So like I said, positive theta is counterclockwise, and then negative theta is clockwise. So I know that it's going to be somewhere located somewhere close to right around here, because this from here to here is going to give me 90, and so then I got to extend it 10 more degrees here, which then this is the negative 100 degrees. So second portion of this section, they want us to find the coterminal angles. Coterminal angles is different ways that you can write the same angle by either positive or negative, depending on how many times you rotate around our coordinate plane. So in these examples here, they want us to find three coterminal angles, one of which they want it to be positive, and another one they want it to be negative. Okay? So I felt that it was easy enough to just kind of make it look like into a graph and kind of identify what that angle is, so then we know what we're dealing with. So negative 215, I know, is going to go clockwise, and I know it's going to extend over 180, so it looks something kind of like right around here. And if I wanted to know, say, what the positive of that is, I could just take 360 and subtract it to 215, and I get a value of 145. So I know that the positive, like this positive over here, is 145 degrees. So saying negative 215 degrees is the same thing as saying 145 degrees. Now, If I wanted to find another value at that same position, I could just take 145 and add 360 to that, which then gives me 505 degrees. So that's another positive value. If I wanted to find one negative, which they're looking for, I can just take negative 215 and subtract it by 360, which then that gives me a negative 575 degrees. So I found three coterminal angles that all be located at that point, and I have at least one positive and one negative. So looking at 570 degrees, I know that it's larger than 360. So if I take 570 minus it by 360, I get 210. So I know, like, when I draw this out, I'm going to go one revolution around, and it's at 210, so it's going to be a little bit larger than my 180 coordinate. So, but since I said it was going to be 210, I know that 210 is a coterminal angle, so I can write that as one of my values. So if I wanted another positive one, I could just take 210 and add it by 360, so that gives me 570. But if I added another 360 to that, I would get a value of 930 degrees. Last thing you could do is figure out what it would be if you wanted to find the negative value of this from here to here. I could just take 360 and subtract that by 210, and I get a value of 150. So all I got to do is attach a negative value to that. So negative 150 degrees would be the negative value for that coterminal angle. Next thing we're going to talk about is we're going to talk about radians. Radians is a measurement of an angle in standard position where terminal velocity intercepts an arc length of r. So it's originated through the unit circle, and it deals with values within pi. So, and we have a conversion equations for being able to get from degrees to radians and also from radians to degrees. So if we have a degree and then we wanted to go to radians, I can take that value for the degree and multiply it by pi over 180. If I have something in radians, I can take that value in radians and multiply it by 180 divided by pi. So from here, I got 75 degrees and they want me to convert it to radians. So all I have to do is take 75 and multiply it by pi over 180. So if I just multiply them across, I get 75 pi over 180. And if I take 75 over 180 in lowest terms, I get 5 pi over 12. So that's 75 degrees in radians is 5 pi over 12. For B, I have radians. They want to convert it to degrees. So I got negative 5 pi over 4. And all I got to do is multiply it by 180 over pi. So since I have a pi in the numerator, pi in the denominator, that I can just cancel that out, which then if I multiply this across, I get negative 900 over 4, and the degree I'm going to be looking for is negative 225 degrees. Okay. Last thing in this section is dealing with arc length and area of a sector. So the arc length is the value or the portion of a circumference of my circle, and then the area happens to be the area of this sector. We have two equations for that. We have, for arc length, we have S equals r times theta, r being the radius, and theta is the angle. But the thing we have to keep in mind is when we solve for this, we must make sure that our angle is in radians. So if it isn't, we have to put that in radians. Okay? So examples A and B, they want us to find the arc length, and they also want us to find the area of the sector. given with the area, with the radius and our central angle. So let's find what S is. So if I take S equaling R, so that's going to be 9 over 50 degrees. But what we talked about is we have to get our degrees in our theta and radians. So just a matter of saying, okay, I got 50, multiply it by pi over 180, and if we have multiply that across and put it in lowest terms, so now I got S equals 9 times 5 pi over 18. And if I multiply this across, I get S equals 45 pi over 18. If you're looking for more of an approximation of this, I can say 45 times by pi. That's about 141.37. Divide that by 18, so that would give you roughly 7.85 inches. To find the area, I can say, all right, A equals 1/2 over, we got R squared, so that's going to be 81. And then I have theta, which is going to be in radians, the 5 pi over 18. So figured all this out. Gives me roughly about, I would say, 81. 81 times 5 gives me 405 pi divided by 36. So that's what, about 11.25, but multiply that by pi. So I get roughly something along the lines of 35.34. And that would be what? Square inches. If we're looking at B, again, I'm going to go S equals, my R is 8. And they say theta is 120, but I got to convert it to radians. So if I convert it to radians, it gives me 2 pi over 3. And if I convert this out, this gives me 16 pi over 3. And that's going to be roughly 16 pi divided by 3, which is, well, roughly 16.76 feet. To find the area, I just go 1/2 over 8 squared. That gives me 64. Multiply that by 2 pi over 3. And so if I have 64 times 2, divide that by 6, gives me 64 over 3, 64 pi over 3, I'm sorry. And if I'm looking for more of an approximation of that, I could say that this is about 67.02 square feet. And that is being able to define general angles and use radian measurement. Hope this helps. Till next time.